your operations, you will find out that energy is one of the biggest ways that you make significant negative impact on the environment. And so we single out energy management to talk extensively on after introducing sustainability because it is the biggest concern that we have of all the sustainability issues that we have to deal with. So in essence, I'm going to spend the first quarter of the class, some 20 minutes talking about sustainability, and then the remaining hour or so will be about energy management. Some practical tips and tricks you can begin to apply now to improve the organization's strategic positioning as a sustainable organization, and also to begin to save costs, improve efficiencies, remove deficiencies from your systems as an energy manager for your organization. That's what we're going to be covering in today's class. Sustainability is that development that meets the needs of the present without compromising the ability of future generations to meet their own needs. This is a Brundtland Commission of the United Nations March 20, 1987 report. That definition of sustainability has remained true till today. Humans or humanity extracts resources to meet its own needs from the environment. The environment includes water resources, land resources, as well as forests and deserts. All of these resources are being consumed one way or the other. Now, the resources we find in these spaces, in these ecosystems, took generations to build, okay? And because they took thousands of years to build in there, we have to be conscious of the rate at which we deplete them. If we deplete them so quickly, the earth is not able to sustain itself or generate replacement for our future generations to be able to have access to these same resources. Then we say we are unsustainable. The earth is a perfect ecosystem, but our own activities, our own operations as humans, especially in the built environment, contributes a lot of waste into the environment. Landfills are being filled daily with junk and stuff that comes from the built environment. All of these impact the environment negatively. If we don't control the rate at which we put things that the earth cannot readily or easily digest, what's going to happen is over the years, the earth is going to be cluttered, congested with things it cannot digest, polluted completely, that when the future generations of humanity comes, they're going to meet an earth that is completely polluted. So the earth is going to be depleted based on the rates at which we extract resources from it, and the earth will become polluted, unlivable, based on the rate at which we dump our waste into it. People work mostly indoors, and air quality is one of the biggest ways people's lives are being affected. Indoor air quality is really, really bad for most urban cities, okay? And so we are talking about facility managers who are responsible for buildings, not only needing to control how they deplete the environment and how they pollute the environment, but also how to preserve lives of the people that you provide services for. Now, to make this practical approach to facility management, you need to consider what we call the 8 categories of sustainability. It talks about energy. Energy is the prime input into our operations. Energy sources include fossil fuels, which are oil, gas, nuclear, solar, coal, and the rest. And then the renewable ones, oil, gas, rather, for fossil fuel. And then you have the nuclear, solar, wind, ocean, turbines as renewable. All these are opportunities for extracting from the earth. We talk about sustainability in terms of using less and less of fossil fuels because the rate of earth regeneration of these fossil fuels, oil and gas and coal, is very slow compared to how much we are consuming. And then we want to increase more of the solar, wind, and ocean, because these energy resources are almost limitless because they restock themselves and we can use them again and again. Then we use water. Water in the earth today is not an infinite resource. We cannot imagine how the earth is running out of water. We have more than 70% of the earth's surface covered by water, but water is scarce because the water people need to meet their own needs is not readily available. Okay, so even if you have it's almost like a case of being by the river and having soap in your eyes. That's how the world is. Most of the water available in the world today is not potable water. You can't drink them, you can't wash with it. The water you just had, saline water in oceans, that's the biggest body of water that we have, right? Now, the water that we can use comes from rivers and streams and underground springs and streams and wells, right? So these water resources, we draw them out, we use them up, we wash with them, we create waste out of them, and we feed this waste back to the same water bodies. So the same way we do with energy, when we draw the energy from the earth so quickly, and then we pollute with pollutants, that's the same thing we do with the water. We draw the water, we use them up, we make them so bad, and then we pump them back into the environment. That is what we're trying to work at. As facility managers, we should be very careful on how we impact the environment. Materials and resources, both in the built environment and all materials used within the environment, are the things that we take things from the earth, we make them into various. We have furniture, we have buildings, we have fabric, we have all kinds of things that we use, stationery and the rest. And then as we use these materials, we have to be conscious of waste. We have to be conscious of the pollutants that these materials bring, including the use of energy and water in the production of these materials. Workplace management, work processes that have environmental impact. Too much travel, for example, means that we're going to burn a lot of fossil fuel in flights and trains and cars, for example. There are so many other operations we carry out, like printing every now and then, that are not sustainable. In the environmental quality, of course, the air quality indoors affects human lives that live within the spaces. And we need to be very careful how we manage our spaces or facilities. Quality of services, are they sustainable? Do we minimize environmental footprints from the way we provide services to our customers? And then waste. Target zero waste to landfills. Can we recycle and compost and reuse materials as much as possible? What about site impact? Do we gauge the environmental impact and footprint of each building's operational process? These are things that we need to consider as facility managers. Now, if you've been operating at the operational level, shop floor, you'll notice that this particular series of giving back has been trying to elevate us up. But we talked about the FM principles. We try to look at high-level strategies to improve our operations. We looked at facility strategic planning yesterday, and that took us to a lot of depth in understanding our organization, the strategies, the mission, the vision of our organization, and being able to align our own long-term plans as facility managers to provide solutions to the organization, right? Today, we're elevating ourselves yet again to strategic levels by trying to position our organization as organizations that are sustainable, organizations that understand how their operations impact the environment, and making every effort to ensure that we can reduce that impact. That's all about what we are doing in today's class. And if you look at the 8 categories of sustainability for facility managers, you can categorize them in terms of input, processes, outputs. Inputs are the things we consume, processes are the things we do, and outputs are the waste that we generate. All right, so we consume energy, water, materials, and resources. We produce workplace, indoor environment, and quality services. And then we release waste and site impact. Waste is obvious. You understand that waste is what we throw out and we try to trash. But site impact also describes how clearing the bushes, for example, to build a structure, interrupting natural flows of groundwater, creating new habitats completely from the natural habitat that we have in place, displacing animals, for example, and birds from their natural ecosystem and things like that. We are developing very rapidly. We are urbanizing very rapidly. These are creating dislocations in our ecosystem, and we need to be conscious of our impact on the ecosystem. That's why we are studying sustainability. So businesses, the organization you work for, is it all about profits? Are we always looking at the economic bottom line? Sustainability demands that we, as facility managers, make decisions not only based on what is cheap, profitable, cost efficient, which is the economic bottom line, but that we are also concerned about impact on people, which is the social bottom line. Have that image that our organization is an organization that cares for humanity, that cares for people, both those within the organization and those the organization is having impact on around us and our direct and indirect publics, as well as the environment. There is an environmental bottom line that looks at the carbon footprint, how much of the waste, how much of the impact of our fossil fuel consumption, for example, and the the waste that we put back into the earth has a bearing or impact on our environment. So when there is a consideration between economic and social bottom lines, you ask if it's equitable. If something that I'm trying to do to save costs is making people ill, for example, is it equitable? If something that I'm doing to make people healthy and happy, is it costing me my existence as a business? Is it going to make us run out of business? I want to be able to create that balance. That's equitability. If we look at the social and the environmental interface, you ask whether it's bearable. People want to live in houses. People want to drive nice cars. People want to live in environments that they like. So they're building and creating all kinds of spaces. How are those spaces we create having impact on the plants and animal life around us? How are they affecting our environment? Is it bearable? If we're making efforts to improve our environment, are those efforts impacting negatively the lives of the people around those communities? That is the question you're asking between social and environmental. And then between environmental and economic, you ask the question, is it viable? Is it viable for you to spend so much of your resources protecting the environment and not be able to run your business or not be able to have any kind of returns for your efforts? Now, being able to create this balance between the three bottom lines, analyze between the intersections of each of these bottom lines and come to that sweet spot in the middle where what you do has a positive impact on people, positive impact on the environment, and it's also profitable on the economic side, then you say you are sustainable. Your activities are checked against equitability, bearability, and viability. And then you can now say you are running a sustainable organization. The way the world is going right now is absolutely not sustainable. There is human activity that is degrading resources faster than the earth can regenerate, right? So that's the main idea behind sustainability. And then with industrial revolution, with global human activities increasing to such an extent, we're going to get to a point where we will be threatened. The earth will be threatened. Biodiversity is going out. Desertification, for example, in parts of the world is increasing. People are beginning to have more crises over arable and farmlands and water resources. There's just a lot that is happening that shows that if we continue at this pace, the earth is going to keep shrinking. The size of the earth will remain the way it is, but the habitable areas, the resources will shrink so fast that there will not be enough for even those who are alive, let alone for those in the future who are coming. The UN has forecast that by 2050, 80% of the world's population will be living in cities. Urbanization is going to be so rapid that in the next 30, 40 years, we're going to see 80% of people living in cities. The world's buildings and the built environment account for a disproportionate amount of the world energy usage. The buildings that we live in and the built environment account for almost 40% of energy use. That's why we're teaching facility managers to be sensible in the way they consume energy. So select the right energy mix that will have the least impact on the environment. FM leaders must be on the forefront of sustainability solutions. And in making decisions, when looking at those equitable, viable, and bearable, what we call the feasibility analysis, you ask questions like, the social benefits outweigh the cost of the initiative? Is the initiative that's producing a positive effect from the environmental standpoint having a negative impact on occupant productivity? Is it bearable? Can the solution be implemented? Will the benefits likely be realized outweigh the costs to implement it? These are considerations you have to make as you take decisions on a daily basis. So what are some of the social measures you can begin to deploy as facility managers? How can the facility impact people who work in it, employees, suppliers, community, and other stakeholders? Think about community involvement. As facility manager, be involved with your community in things that have to do with community development. How do we manage refuse around there? How do we clean our drainages? How do we manage effluents and emissions into the environment? What about the people that come into our building? Are we caring enough of how well the air inside, the environment inside, the ambient inside is for those who are using our buildings? Are people sick because they are coming to our buildings? Are we creating healthier environments? Is our environment safe? All this calls to question our ability to commit to the lives that we hold in our hand. Because every time somebody comes to your building, you're actually holding the person's life in your hand. What about environmental measures? The organization's ability to avoid harming the environment and preserve scarce resources for future generations. You want to reduce an organization's environmental footprint. Energy consumption is the biggest environmental impact, and that's why we always put it first. Waste, reduce waste, reuse and recycle, decrease the carbon footprint, decrease and eliminate hazardous materials. There are so many materials that we use, like asbestos, like mercury, like, all kinds of things that we use in our facilities, lead and the rest, that we shouldn't be disposing anyhow because of their impact on the environment. And then create building processes that abolish toxic materials. On the economic front, the FM should be able to create value for the organization by controlling and lowering operating costs. Every time you control or lower your operating costs, you are contributing to profitability. So even if you are not selling or you are not producing or you are not directly creating the profit, every time you are able to save on the cost of running your facility, you are definitely adding to profitability of the organization. So we talk about asset value increase because we are maintaining well, because we are operating well. Higher return on investment because we're able to use our assets for their useful life and we're able to get value back from them. Higher efficiency and long-term savings come from that effort. Should you start implementing sustainability initiatives right now? The answer is yes, because most organizations are now fully aware of sustainability as a way to, not just to a way to give back to the community and the environment, but also to position our organization as a premium organization. A sustainable organization is seen as an organization that creates high quality and high value. People tend to pay a premium for the services or goods of an organization that is adopting sustainability. But as an FM, you must understand that there must be alignment between your sustainability ideas and the mission, vision, values, and corporate objectives of the organization. So what does that mean? It means that you will look at the organization's direction and begin to bring up initiatives, sustainability initiatives that helps to further that, that aligns with that organization's strategic objective. So you don't create sustainability ideas or initiatives that will run counter to the strategy of your organization. So that's the first thing. How does sustainability fit within your organization's mission, values, and corporate objectives? And then you begin to ask questions. Is it embedded already, or is it something you need to start beginning to talk about and ginger people to start talking about sustainability? All right. it has to become a way of life. So it's not something that you create as a project and then get a buy-in or approval to execute, and then you say we've done sustainability. No, sustainability becomes a way of thinking for everybody in the organization. So where do you begin? You start with understanding that sustainability is not something one person does. And once you understand that, you begin to put down certain what we call baseline metrics. Baseline metrics are measures of where your organization is right now in the 8 sustainability categories. Okay, we talked about water, we talked about energy, and so on and so forth. If I'm running my facilities, do I know how many liters of water I'm consuming per day, per month, per person in the building? Do I know how many kilowatt hours of electricity am I consuming, and so on and so forth? You know what those basics are, okay? And then you begin to use that data to establish like a gap analysis of what actions you can take to move your organization from where it is to a better place with regards to sustainability. Determine the what and how sustainability metrics that are to be measured. Plan in advance sustainability initiative from the vantage point of anticipated cost or cost savings. You know, it's often easier for management to relate with you or to understand when you start projecting sustainability from the aspect of cost savings and operational efficiencies. All right, so that's like your beginning point, to speak the language that they can relate with, which is the language of cost or profitability. But then as you pick up initiatives, start with the low-hanging fruits. For example, you are changing out fluorescent tubes. Instead of changing out fluorescent tube with fluorescent tubes, you start using LED fittings as replacement for fluorescent tubes as part of normal operational replacement of light bulbs. That way, you are optimizing energy use by reducing energy consumption. At the same time, you are not even creating a new budget. That is a low-hanging fruit, for example. And then, of course, develop milestones on how you're going to implement certain activities along the way. Get people to work with you, document sustainability measures, and as you make little success along the way, ensure that you celebrate, you understand what achievements you have made, and then you communicate. So because sustainability is not something that one person can do, it's important that you have your bosses and management signed up in such that you have made some efforts to translate the low-hanging fruits and the quick wins you have achieved into something that you can present as a report of value that you have created. That way, they begin to see sustainability as something that they will want to support. So they begin to buy into sustainability, all right? You solicit support from senior management because you can't do it alone. You can't begin to push at the bottom. You cast a vision because you most likely need to work with people at your level, people in your team, sometimes other departmental heads to start beginning to rub minds and share ideas on how you can become more effective in providing solutions to them. Then yes, that vision is what will propel them to even start thinking like you think when it comes to sustainability. And then as soon as that is done, you create a series of short-term, mid-term, and long-term sustainability practices that you may want to start introducing, starting with the short-term ones. How can we get everybody to put up their light bulbs, for example, when they are leaving the office? How can we automate the process of air conditioning going off when people leave a space so that the occupancy sensors can be installed and so on and so forth? We begin to put, different types of activities. Those are short-term things that we don't need CapEx budget for. We don't need to put them in next year's OPEX. We can do them right now and they will not cost us anything, right? Next year's operations budget can cover certain activities. We could also have CapEx budgets provided for something, but then we are looking at how we are going to show return on investment to management so that they can have commitments to the strategies or initiatives that we are bringing and putting in place. Okay, so the whole idea of sustainability is you think it, create plans on how you can embed it and carry others, including your management, along. So because energy efficiency is our key focus today, we're going to just talk about a few terminologies about energy and electrical use. We're going to look straight at energy management, energy efficiency, energy audits, and energy submetering in today's class. So the first thing that you should understand is that everything you plug into power consumes electricity. We call them loads. Different types of loads exist in your facilities. There are those you call the resistive loads, things that are mostly based on elements. They draw power and in such a way that current and voltage are in the same phase, right? So engineers will tell you that, but if you look at the examples, lamps, oven, heaters, toasters, you will get a clear understanding. They tend to use elements to work. Inductive loads that use magnetic fields for their work. These are loads you get in coils. So motors and transformers are using inductive loads. And then capacitive loads are different from resistive and inductive loads in that they exist in a standalone format. They're included in electrical substations for improvements of the overall power factor of the system. The capacitive loads, synchronous motors, generators, capacitor banks, etc. More definitions: electrical power, the rate at which work is done in an electric circuit. Simply put, it is the rate at which electrical energy is consumed in an electric circuit. And watt-hour is the unit of electrical energy, the equivalent to power in watts consumed for 1 hour. So if you consume, how many watts do you consume in an hour? That's your watt-hour, all right? Energy conservation refers to energy savings. Of course, we know what that is. And then every effort we make to save energy is what we're looking at in today's lesson. But the basic way we consume electrical energy is through circuits, all right? The path through which electrical current flows. Electrical current is what our loads actually consume, all right? So take the example of a bulb. There is a connection that links the bulb to the energy source. That energy source could be a generator, a battery, an inverter, a solar, whatever it is, and then connects back with conductors or wires and control to ensure that the energy source is consumed. So if this system is left closed, for example, the energy in this battery will be consumed entirely by this bulb. That's how everything that we plug into our energy system operates. Energy management, of course, is the way we control how we use energy. So our loads, our energy sources, what is the relationship between the two of them? That's what we call energy management. If you're already groaning under the weight of high energy consumption, high bills, high costs of producing or generating power, you are at the first level of awareness of energy management. You begin to think about energy efficiency. You hear people start saying things like, switch that off, switch it off, change this to this type of load so that we can have something that consumes less energy. Energy efficiency has been in our vocabulary for a long time. We always think about it, but how much we practice it is then the real question. And then we take a lot of, we take a lot of steps to try to implement energy management or energy efficiency, but the basic means of measuring and ascertaining whether the efforts we have made is yielding the results we often don't implement. For facility managers, it's important that you know how energy is bought in your facility. Many of us know how much we pay for a liter of diesel, but how many kilowatt hours does that liter of diesel produce? We really have not sat down to do the calculation, and that is sad. You know how many kilowatts, how many naira you pay for a kilowatt for the public supply, the grid that supplies you. You should also know how much you pay for a kilowatt hour in the one that you generate by yourself. And that requires that you understand, one, the cost of the fuel that you're using your generator, two, the cost of your generator itself, the cost of that equipment per period. For example, how much that generator costs per month, per day, per hour, whatever. So you can use a factor of that to add to the cost of the fuel, and then you add the cost of your maintenance to that, and then you use that to divide the total energy produced in kilowatts for that period, and you get your kilowatts, your cost per kilowatt hour. And it's very important that FMs are able to do this simple calculation so that you can compare whether what you are producing is cheaper or more expensive than what you're getting from the grid. And if you know the difference between the two, when you now know the percentage availability of the grid to you, in case the grid is cheaper for you, you can tell how much your cost can go down if one or the other is increased. For example, if the grid is cheaper by 30%, if the grid increased supply from 50% to 80%, how is that going to affect your total energy cost is what we're talking about as facility managers. It's important that we know, okay? Two dimensions will be addressed in energy management: the technical aspect, energy consuming devices and systems that use energy efficiently or inefficiently. You must understand how your load or devices are consuming energy. And then the organizational aspect has to do with structures and management systems that can support or hinder the achievement of energy efficiency goals, as well as then the behavioral ones, with attitudes, personal values, and practices of individuals in the organization that impact energy use. So the organization one has to do with processes that make things to run without considering energy efficiency. Whereas behavioral ones talks about the individual culture and activities, individual behaviors that affect energy consumption. But before we start talking about energy efficiency, let's talk about the sources of energy. There is the fossil fuels, which is not renewable, and then you have the renewable fuels, the nuclear fuels, solar, and all the others. Our purpose in energy management is to improve energy performance. We don't necessarily want to reduce energy consumption, because the expectation is that if you use more energy, you are producing more and you are becoming more, you are becoming richer by just using more energy. That's the expectation, right? So when facility occupancy, for example, is high and operations increase, energy consumption is bound to go up with it. Your CO2 emission as well. So when occupancy is high, it means that we have more people who are working, right? It means that we're producing a lot more. Now, so instead of focusing on the energy cost driver, right, which is the number of people or the space we're managing or any of those drivers, we're looking more at metrics, which is performance. So performance simply means that I'm providing, if I'm providing a million megawatts hours of power in a year, for example, how many people am I providing it for? If I'm providing it for, say, 1 million people, 1 million man days for each person, I'll say, oh, well, I provide 10 kilowatts per person per day in this facility, right? Now, it is possible to have that person work, produce all the results it's currently operating and producing for the organization at less than 10 kilowatts hours per day, right? So that's exactly what I'm trying to work on. I want to ensure that more people can work, but the unit rate of consumption of energy is reduced. So I can use the same machine that produces 100 units to produce 100 units at a lesser kilowatts or wattage per unit produced. That's energy performance. What's important is that you continue to improve your energy performance as you increase energy consumption, okay? So improve energy performance measured in terms of cost, absolute use, or with various energy use ratios, such as kilowatt hours per additional unit. Those are the drivers on how you use energy. So we talked about the energy sources already. They are primary and secondary. Primary energy sources are those embodied in natural resources like crude oil, natural gas, uranium, coal, and the rest, right? They are transformed into secondary energy through conversion. Mechanical power, heat, electricity, basically by burning them. Renewable and non-renewable energy sources are a form of energy from geophysical, solar, or biological sources. They are replenished by natural processes at a rate that equals or even exceeds its rate of use. That's why it's called renewable energy, right? So we think about solar, we think about hydropower, we think about wind, tidal, and wave power, ocean and thermal energy from geophysical structures on the ground, and so on and so forth, including things like biomass. If you plant a field and you harvest the entire field and use generated energy, and then you plant again and you generate so quickly in a few months, you get what you're looking for. So focus on these key goals as a facility manager. Use less, not less overall, because you want to be more productive, you want to be expanding your business, but use less per unit cost driver or energy consuming energy use driver. Use more energy derived from renewable sources, which means as much as possible, even if you cannot do without fossil fuels, right? You can reduce that as much as possible by installing, solar technologies in your facility, just to reduce the amount of fossil fuels that you deploy. For example, you could have a site where you have a very large generator, and that large generator, anytime there's need for power, that's the only thing people fall back to. So even when you have a 1 MVA generator, for example, and at certain times of the day when not many people are in the facility, or at night when the demand is very low, the expectation is that if you are running that large system, you're actually wasting a lot of resources. So why don't you switch those kind of times to systems that have been stored from solar, as a backup, so you can save on fossil fuel consumption and reduce that impact on the environment. You're reducing cost as well, because of course, over time, you're going to save a lot for not burning that fossil fuel. But you have to add both as value to your organization. You're reducing costs, you're also reducing environmental impact. Use energy in a more socially and environmentally responsible manner. That you can afford it does not mean you should expend it. Okay, I've seen situations where people put up a tent, open to the environment, close here and there, but then they put up that tent and they have this massive standalone units to cool people inside that space, right? Now, you get those systems to run around the clock. They consume a lot of energy throughout that period. You kind of wear them out because you can afford it. That's what we're trying to get out of. Sustainability requires that even if you can afford to waste that energy, you do not waste it, because the environment is not entirely yours. It's a rented resource that future generations should come and find something to use inside. You need to understand your facility's energy consumption and purchasing. What kind of meter do you have? What kind of supply do you have? If they say you are on C1 or C2 or whatever code your consumption code is from the public supply, what does that mean? Have you taken time to interpret that? How much is your cost per unit of energy consumed? Do you know that? Improve the efficiency of core building systems. I just talked about tent and air conditioning in tents, but some of our buildings are just like that. The building system is so dilapidated that every time you're trying to cool or heat internally, you are actually trying to cool or heat the entire ecosystem or the entire environment of the gardens. You improve the efficiency of your building to conserve mechanical heat or cooling generation energy within your facility. Optimize facility energy use. Involve occupants in energy initiatives. There's really not much you can do as a facility manager to entrench energy efficiency in your facility if you do not involve your building users. Occupants, if they are committed, will give you a huge gain in savings. If they are nonchalant or not committed to energy efficiency, then there's very little you can do. So you have to spend enough time trying to win their hearts and win their minds to energy efficiency. Because it's not just about how much you're going to save for the organization and how that's going to impact their own livelihoods as the organization gets richer, but also seek to reach out to your colleagues and your teams to understand the impact on the environment of this wasted energy. Reduce heating and cooling load through improvements made to the building envelope. Identify energy used by all core system components and improve the efficiency of individual systems. So you take your heating, ventilation, which is the air conditioning system. You take your transmission system, elevators, and the rest. You take your electrical system, DBs and panels and transformers. You look at all the systems, your plumbing systems, and you ask yourself, how efficient are these systems working for me? If they're not working well or they're consuming too much energy, what you basically want to do is to find ways to improve it. Potential energy savings look small compared to the total turnover of the organization, but they are much bigger if seen as part of the operational cost. Energy that we consume in our facilities, in some cases, can be up to 50–60% of our total operations cost for that facility. So it's a huge aspect. And if your operations cost for your facilities, we all know that facility management costs are the second largest overhead spenders for organizations. Energy is the most significant inside the facilities cost, right? If you can manage your energy cost, there's a high likelihood that you'll be contributing to savings and profitability of your organization. And for you to know where you currently stand with regards to energy efficiency, energy management in your facility, you need to order an energy audit. You cannot manage or improve what you do not measure. The energy audit seeks to document things that are sometimes ignored in the organization, such as energy being used on site per year, which facilities or buildings use the most energy, opportunities for savings, and so on and so forth. Okay, there are no cost operational maintenance adjustments that can save energy, like people are ignoring. There are also short-term and low-cost energy efficiency retrofits. There are certain repairs that you can do to some equipment that would reduce drastically how the equipment draws on the energy that you supply. And then, of course, action plans for energy efficiency, capital investment. If you're going to improve your energy, your building facade or your envelope, for example, so that you can improve your energy efficiency, it's a lot of capital investment. But of course, you need to do your energy audit to know whether there are these deficiencies in your facility. That's the most important reason why you need to do energy audit. When you are doing an energy audit, you could easily just do a walkthrough. Look at your lighting, look at your building envelope, look at your air conditioning system, and all the other equipment that are installed in your facility. You are doing an inspection, you are documenting your observation, and you are taking some real-time measurements of how energy is being consumed by the various aspects of your facilities. And then you begin to create an action plan. Some of the things that will come out of your energy audit includes measures to monitor building systems performance. Okay, so you have to consider energy management system. We'll introduce one to you in a bit. You need to look at how maintenance practices like poor connections, leaking insulation, undersized conductors, and even power factors and voltage imbalances can create energy loss, and begin to correct these things. So in essence, these are things that are helping you to consume enough, waste energy in your facility, right? Because you perform an energy audit, it's now easy for you to create systems or plans to optimize your energy facilities, including the micro ones, like leaving your laptop and computers on for days, they drain and you recharge them. There are also big ways, especially if you're in the maximum demand billing system. Those of us that have point load transformer in our side, we're so proud about it. The way our energy consumption is calculated is quite different. All of you have skipper meters. You realize that you can't just read off the face of the meter the kilowatts consumed, right? That's because your peak plays a major role. It's a major factor in how energy is calculated for you, right? So you get your bill and you'll be wondering, oh, why did they tell me I consume 30,000 kilowatt hours? How possible is that, right? Because you are not controlling your peak. Your peak load, it can be a big problem for you. So what does that mean? As at the time you are having all of your facilities running, your lights, your air conditioning, your heaters, your water pumps, and everything running at the same time, all the people that should be in the building at their maximum extent are all in the building. You are at your peak. That peak needs to be dropped. And to drop it, you use either load shedding, where you cancel certain activities permanently out of peak period. For example, you shut down the facility for break time. Everybody goes and leaves the facility. When they are out, Whether they're in or out, well, it's their business at that time. But what you're basically trying to do is you're shutting the entire cooling system for that period. That drops your peak drastically. And then you consider some other things like machines or pumps or motors, sewage plants and others that necessarily can work else at other times. They shouldn't be working at the same time at the peak. Okay, when you want to practice load shifting, you switch equipment away from that auto, the flow switch thing where you have it automatically starts when it drops below a certain level. You switch it away from that, and you probably install another kind of control that automates it to fill up or work at certain hours. And then when it is filled up and it's completed its processing for periods when the building is at peak, it gathers, what it needs, for example, to do more work later. So you could do your pumping of water at certain times of the day. I pump water in the evening, I pump water in the morning. These are both off-peak periods. Instead of allowing the water to drain to 70% and the pump picks up again when it is 1 o'clock or 2 o'clock in the afternoon. Those are ways I can manage my peak consumption. But again, the most important thing you can do for yourself and your organization is to ensure that you have an energy management system. We still have facilities that are metered in bulk, like they say. So you have multiple tenants, multiple users in the facility, and you all have 1 meter, and you are doing every month calculations of how to share the bill. Should we share it by square meter? Should we share it by how long you're in the house? Should we share it by how much this and that? Now, you'll find out that in fact, the reality is that until you actually meter at various unit levels, at the basic, meter at the individual occupants. And then beyond that, meter into equipment, meter specific equipment. You have a borehole, you have an elevator, you have a chiller system. Meter them so you can get a sense of what they are consuming to produce the utility you are getting from them. You meter them to also get a sense of whether they are still in good working condition compared to when they were installed. Manufacturer says this is going to do 40 kilowatts and is now doing 55 kilowatts. That tells you there is something fundamentally wrong. It will still be working, but look at the difference: 15 kilowatts or 20 kilowatts extra. If you calculate that over the years of number of hours that thing will run on a daily basis, you know that you are wasting a lot of the resources of your organization. So we talked about remote energy monitoring that provides technology and know-how to guide, measure, and help manage energy use and costs. Real-time data collection, analysis, and reporting is required if an energy baseline, energy targets, and energy performance indicators are to be identified for your organization. Energy management and verification demonstrate the value of energy efficiency program by providing accurate, transparent, and consistent assessment of facility energy performance. So you might think that, oh, well, if we just change our windows to double glazed windows, we can save energy on our air conditioning. If you do not meter the air conditioning system itself, all that investment you put in the windows and the envelope of the building, you cannot tell whether you're actually getting results from it. Sometimes you go ahead and change all your lights, you're taking all lights out, we put LEDs in the lights, right? So, oh, by now our bill should go down. By how much is it going down? How can you know if you do not particularly meter the lights? So that's what we're talking about, metering at circuit levels. The benefits are enormous, but I'm going to start by talking to you about a solution that we have for energy submetering, any scope solution. The most complete energy management solution in the world, helps you to identify waste and eliminate cost, combines unmatched hardware with a class of its own, a special class software. What Aniscope does basically is you have this kind of real-time data. You can assess every device, every space that you have in your organization. You can tell what is consuming power right now. You can tell historically the last 1 hour, the last 1 week, the last 1 month. You can tell aggregated. You can set it up across locations in your organization, and then be able to say, this is how much this unit is consuming, this business unit is consuming. This is how much we spend on cooling for 1,000 people that sit in 200 places of power or 50 places across the country. You can have all of those kind of data, and you can measure everything from your cost to your carbon footprint, voltage, real-time voltage, power factor, kilowatts, which is your energy consumption, and so on and so forth. So you cannot play with this kind of data. You can't. The investment in a system like the Enniscope will save you far more than you can imagine in energy savings. So that's why we are so confident in Max-migold, because we are the original manufacturers representatives for West Africa for the Enniscope. And so we are so confident about the solution that just this level of real-time data can help us pinpoint, pick out, and eliminate all the waste in your facility before we even start looking at retrofits, that we can offer the Enniscope management system to any facility where your energy bill, your total energy cost in a month is already more than 3.5 million or above. We can install it for free, reduce your energy costs at our own expense, and then take that savings and split it to pay for the cost of deploying the Enniscope system. So you have nothing to lose. You've been losing all these months and all these years. It's time to stop, make a rethink. You don't have to think about a capital investment. You don't have to think about anything else. You just know that you are going to stop wasting all that money now, and you're going to do it for free. So you make decisions about energy upgrades by comparing energy use in similar facilities, focus accountability for building operation on the facility department, facilities charge back. So departments, when you want to now say business units should be handling their own profit and loss, they do their own P&L. You want as facility manager to be able to exactly tell them what their real costs are in every aspect of facilities. You can also do that for energy, charge back their energy costs, okay? Assist in developing cost recovery and overhead analysis, as well as verify savings from energy improvement projects. Guide maintenance decisions. Monthly and annual energy use trends helps to identify operational or potential benefits from system upgrades, such as component replacements and improvements. Now, as facility managers, I see a lot of people managing estates, and they are always having issues with how to share bills. You don't need to share bills when you have an energy management system like this. Even if it is complicated wiring, if I am metering at the circuit level, at the dB level. By the way, this device, this Enniscope device, is capable of metering 24 circuits, 24 channels, single phase, or 8 channels, 3 phase. What this means is that I can have one in my panel room where my incoming, my generator outputs, my power distribution into the various buildings or floors in my buildings are captured. I take all of those, they have three-phase distribution. I meter all of them with one of these. I go to each of the floors where you have the distribution boards, and all of those, your 12-way, 16-way, 32-way dBs. I install one of these beside, and then I meter every important load. If I want to meter every load, lights and sockets and everything, I will label all of them on the dB, label all of them inside the software, so that by the time I get to see the back end, it will tell me what circuit this is. Is this 124 kilowatts being consumed by a light circuit that has maybe 50 lights in the ring circuit array, or is it an air conditioning system, an air handling unit that this is? It will be labeled clearly. I can tell when a device that should not have been switched on is switched on overnight, because I can wake up, check the system, and see that that device ran power. Even if it is switched off before I get back, I know that it's ran because I can look at the historical data. Okay, so that is about energy monitoring using an energy management system. Your bill distribution becomes simplified. Nobody's arguing that you are not being fair. The automation is so sweet. You can even get the client to log in to the system to see how their energy is being consumed. They can tell exactly how much different between their freezer and their cooker in energy consumption, because they will see each one labeled clearly for them. You can see how effective that will be in energy cost. And for those of us who manage communal areas or office environments, everybody begins to see their impact. Okay, so if you have wing A and wing B, and wing A becomes more careful in managing their energy, for example, they are switching things off, and wing B is not, you can create some kind of gamification of the process. Start throwing up those numbers in the organization to see who is doing well, who's not doing well, and see how that, that getting into the hearts and minds cannot really happen if you cannot show them data. They see what they do and how what they do impacts energy consumption. You throw in the cost into it, and that's the beauty of the energy scope as well, right? So you know how much your kilowatt hour costs. You throw that in as well. So they know how their behaviors are impacting not just the cost of facilities, but profitability of the organization, because every money that we waste goes out of profit. Every money that we save goes back right into profits. So you perform energy audits. Your energy audit is inspection. Your energy audit is also setting up. So for example, you can have the energy scope used to conduct your energy audit. We install it everywhere. We download data that shows a certain date range. All of the analysis is done, give you a sense of your energy profile at the time. So if you decide not to install a full live standing energy management system that gives you continuous day-to-day monitoring and eradication of waste, you might as well book a series of energy audits twice a year, for example, where the Enscope devices are brought in, configured into your facilities, and they're non-intrusive. They're not like kind of meters that you take a cable and connect it into it, and the current or the power runs through the meter. No, that's not how the Enscope works. The Enscope is actually a computer device. It uses current transformers that are kind of hung around your cables to sense how energy and all of those quality of electricity is running through those cables. That's basically what you are trying to do. So you could have, whether you are residential or commercial, energy audit will serve everybody's purpose. It's something that helps you to develop a strategy to prevent wastage. If you don't know what you are wasting, you cannot say you're preventing it. Okay, so that's the whole idea of setting up. Either you have an energy management system in place, or you move to using it as a system for knowing at certain intervals. So if you set it up, you make a change, you see what the readings are, you take it out, and then later, when you begin to see the bill ballooning again, you can order another energy audit. But our advice for you, if you really want to get the best, most efficient outcome or output from your energy efficiency, is to make sure that you set up an energy management system. It takes away all the headache that you can that you probably are experiencing with regards to energy. The energy audit process, of course, you can conduct energy audits yourself. All right. So while we have specialist organizations like Max-migold that conduct energy audits using the Enscope and other analytical tools that we have, you can also do in your own way, do some surveys where you use your clamp meter to take certain instantaneous readings across facilities to get a sense of how much they are consuming. And then, of course, you can use that data, but that data you cannot say is accurate, because a particular device might be running at its highest consumption by the time you came to take that reading. Take, for example, your air conditioning system. When your compressor is on, the air conditioning is trying to saturate the cooling to the thermostat setting. It will be running at very high energy consumption. When the temperature has been reached in that surface, the compressor shuts down automatically, because the thermostat says, I've reached the temperature I want to have set, you are set for that particular room. Now, when the compressor shuts down, the consumption of that AC at that time drops dramatically, drops to maybe sometimes 20% or 30% or even less, right? So if that's the time you put in your clamp meter to get a reading, in amperes of what that AC is consuming at that time, you're making a big mistake. So that's why you need to have an energy management system that, has a continuous reading, real time, recording all of those, and you can get your averages, you can get your peak, you can get your lowest from those kind of data, okay? And then of course, you create your energy audit checklist, significant energy users, and then operating parameters of those energy users. You want to focus on the biggest energy consumers in your facility. That's the main attraction here, because if you're able to focus on the biggest energy consumers and you're able to identify wastage in them and save, then of course you definitely feel fulfilled or accomplished. Okay. So these are some of the things that engineers that will send to your sites will do when they are taking your energy, your audits, just to help you get a sense of what an energy audit is and the kind of data that we're going to put together and how we're going to suggest or create a kind of a remediation plan. So if we do come for an energy audit, what you will have is not just your energy profile, energy use profile. What you will have also includes all of those electrical defects and building code non-compliance that you get from the way you use your facility. So when we are coming up with remediation plans, it's going to both take care of energy use as well as take care of defects. Okay, and take care of defects on its own also ensures that energy use is controlled. For example, when your equipment are developing a fault, when they are going bad, they tend to draw more power. And that's what you want to watch out for. Okay? And then, of course, the final report is not just going to list out all the problems. It's going to also list out the solutions. And then, in our own case, we'll provide a market costing for that remediation and do a return on investment analysis for you, so you get a sense of how your investments to improve your energy use or energy efficiency will be paid back when you spend that money on it. So if you're doing it on your own, of course, you could do we have different levels. You have the walkthrough or preliminary energy audits. It's the simplest and fastest type of audits. Involves minimal interviews or meetings with the on-site personnel. It only focuses on the significant problem areas. Corrective measures are described briefly, and quick estimates of implementation costs, potential operating cost savings, and simple payback periods are provided. It's not sufficient for taking a final decision on implementing proposed measures. Still, it is adequate for prioritizing energy efficiency projects and determining the need for a more detailed audit. So when we talk about those low-hanging fruits and quick wins, yes, you can just look at an equipment making so much noise, heating up, unnecessary, and say this equipment is consuming more energy because the heating and the noise that we are seeing and the vibration we are seeing are energy being wasted, right? So that is something that you can use a walkthrough energy audit to identify. You see a room that's trying to chill or try to cool, and you see that the windows cannot close properly. The windows are always 2 inches ajar, right? So those are the kind of things you can deal with this approach. So you don't only look at buildings, you also look at utility bills. What are the trends in your utility bills? For example, people that use the facility, having chats with them to ask them, when the things go off, do you put off things? Is there an automatic means of putting it off? Or do we just forget every now and then, or we go on break and come back and leave it running? So those are the kind of things you do at this level. At level 2, which is general audits, it's methodical and systematic. You quantify all aspects of the organization's energy consumption, recommending non-capital expense energy consumption measures and capital expense energy efficiency measures. This audit includes determining the energy baseline. So you actually need to map out the entire energy use of the organization. You must be able to simulate how energy will be saved within that organization. So this is more detailed, and you might need professionals to come in and set up an energy management system. So I'm going to wrap up now by looking at some of the things that we use in our facilities and what to look out for in when we are doing energy survey, energy audit, so that we can pay attention to steps we can make or take as individuals or professionals in our fields to reduce our energy consumption. Lights are so pronounced, they're bright, they're everywhere, okay? But is it possible that lights are coming on when they should not be coming on? Is it possible that lights are coming on and staying on in all occupied areas? Are they coming on during the daytime? For example, security lights that should be off. You have a way of harnessing natural lighting to reduce how much of your procured internal electrical lighting that you use. Then you look at the physical appearance of your light fittings, the lamps, lessons, and light reflecting surfaces. What do you see? The greasy, dusty. You have insects inside some of those fittings. Now, you might have the light beaming itself so bright within those casings, but you're getting very low luminance, okay? And that is probably the reason why you are consuming a lot of energy. So you put on a lot of lights because all of the lights, each of the lights are dirty and bringing less luminance as it should be. And of course, there could be some overlit areas. Lighting fixtures give more lighting than required, can be a problem. It causes discomfort, but of course, you're also spending money in doing that, right? So you talk to those who walk around spaces and find out if the light luminance or the brightness of the lights is adequate for their work. If not adequate, of course, you need to look at the social implication of having inadequate lighting for people, the impact on their eyes and their well-being. But if it is too much, reduce the discomfort, but also reduce the cost because you are wasting money already. And then, of course, you have obsolete lighting equipment. Your lighting equipment can still be the old sodium light bulbs or ballasts or some, fluorescent tubes that you think is just okay right now. There are more energy efficient systems, right? You may not be able to get the capital funding to replace 3,000 lights fittings in your high rise, right? But you have enough to buy fluorescent tubes to replace maybe 5% of it every 6 months or 10% of it every year, for example. Now, if you convert that budget, maybe with a little help, into a fittings replacement arrangement using that OPEX budget, such that if I have need to buy 100 tubes across various locations in the facility, what I'll simply just do is take out one room or one hall where I have 100 working fluorescents, use them with their fittings to go and replace those ones that are burnt out, that are dead, right? And then the money I should have used to buy 100 fittings that would have covered all of those areas, I use them to buy LED fittings and install in this one hall. I can take it one space at a time, and trust me, the costs are now becoming so similar. It's looking almost the same now if the LEDs are not even getting cheaper by the day. So think about it. And then your electrical systems. We talked about the peak demand aspects, or especially if you're on the maximum demand, using load shedding and load shifting, improving processes to minimize electrical power requirements, improving the power factor of your facility. You can install devices to help improve power factor. You can also do take some corrective measure to improve power factor. And then shift energy consumption to a time when energy costs are lower. Of course, we often don't have that disparity on energy costing according to time of day or night. But again, you can reduce the overall energy measured in kilowatts consumed in your facility. So you can do that because you are actually measuring, because you have a metering system in place. If you don't, of course, you cannot, okay? Turning things off. If people will not turn things off, of course, that's your first effort, get people to turn things off. Then you can think of simple technology that can help you automatically sense that people are no longer there for the lights to go off on their own. They are called retrofit systems. Okay, equipment needs to be shut down. Use of variable speed drives in chillers and other equipment that uses pumps, so that motors can be have automatic soft start technology deployed. These are things that you can find available as technology in the market to retrofit, improve. You actually get your system to work better while you are looking at energy cost reduction. Okay, you may have electric motors that you think they're still working. Let's keep managing them. Compare the energy consumption of this old rickety one you are having with the one that are more modern, that can do probably half the energy consumption. And you'll find out that running the old one for 6 months is enough to buy a new one. Make the case, and I'm sure management will look at it easily. What about your air conditioning system? You know, for us, the air conditioning system seems to be the biggest consumer of our energy, especially in the tropics, because we have to use it virtually around the clock. We cool up our spaces. Okay, so one thing you can do is to improve your building fabric. Okay, so make sure that your building is properly insulated. Make sure that you have thermal control, thermal insulation. So if I look out, if I touch my window from outside, when my inside my space is cool, my window should not be cool from outside. My window should be hot from outside, because outside is the heat on that window. If my window is cool inside and it's also cool outside, it means I'm losing the energy I'm using to try to cool my internal spaces. Reduce light where possible, add insulation to hot surfaces, isolate heat generating equipment and provide local exhaust and make up air, block unneeded windows, install time clocks to shut down the air conditioning system, install self-regulating controls for both lighting and ventilation systems, install variable speed drives. We talked about this a little bit for chillers. That can save fantastic amounts of energy, up to 40%. Prevent unauthorized adjustments for tampering of cooling settings on the air conditioning system. Some people just go outside, they've been working in the heat since, they come into your space, and the next thing they want to do is to ramp up your cooling. They just drop it down to 15 or 16 degrees. You must make sure that there's control over who can use your air conditioning system, especially for those massive chiller systems that when somebody controls it, it sends signal to the chiller to start dropping further the temperature of the water that it is bringing into the air handling unit, and that can be a significant energy wastage. And then your fans and your pumps, they use motors and they use drives. Being able to use VFDs will go a long way in reducing your energy consumption. When you have vibration and noise and heat taking place in your pumps and your motors, those are energy losses. So fix them and your energy consumption will go down, okay? And there are so many other energy reduction measures for motors. So when you have, and then there are so many places where you have motors, your escalators, your elevators, your chillers, so many place opportunities to look at how motors drain your energy. Use synchronous models to improve power factor. Under voltage and over voltage conditions should be checked. Check alignment. Use energy efficient motors where economical or needed. Balancing of the three phase. Phase imbalance is also a very big issue. Unbalanced voltage can result to induction and input power by 3 to 5%, sometimes even more. Energy efficiency measures for drives. Using of variable speed drives for large variable loads. Using precision alignment. Checking belt tension regularly. Using of high efficiency gear pulley. Putting them off when they are not in use. Elimination of inefficient couplings. These are also applicable for factories and manufacturing systems, just to make sure that you paid attention to what could be costing you energy. And then for fans, they help to move air around. You could have a pressurized stairwell for evacuation. You could have ventilation systems that are operated by fans. You reduce forced draft fan and inducing draft fan power consumption by minimizing excess air level in combustion system. Minimize inleaks and outleaks in air conditioning systems, having major impact on energy efficiency and fan power consumption. Replace impeller with high efficiency impellers, where the impellers are no longer efficient. Downsizing as needed by impeller derating, all right? So replacing with smaller diameter impeller. Adopting inlet guide vanes in place of discharge damper controls. Using smooth, well-rounded air inlet cones for fan intakes, minimizing fan inlet and outlet obstructions. For your pumps, questions to ask when considering energy efficiency for a pump. What do I need to know to install a new pump? How do I expand my existing system? How do I make existing system more efficient? Do I need a new pump or pumping system components? We use pumps mostly for water, for other fluids in and out of our facilities. We need to ensure that we have controls. VSDs, variable speed drives, are also very important because pumps use motors as well. And then ensure that you don't oversize pumps, use high efficiency motors, and make sure there's maintenance in place. What about electric ovens and heating elements? If their casings or their doors don't close well, the heat is being lost. That's a loss of energy. Switch it off when it's not in use. Instead of letting it run for just a small quantity of preparation, you want to make sure that you use it to capacity. Defrost food before cooking, of course. If you put it with the ice in there, you have to use a lot of energy to defrost it before you get to the cooking stage. And then cleaning of your oven is also very important. If it cakes and you have things coating the surface that have not been removed, that affects your energy efficiency. And then the devices you use to put things inside your oven also matters. Use ceramics as well. And then your water heaters. We use water heaters. Many of us leave our water heaters on very high thermostats, leave it running around the clock. It boils. We use a little out of it or don't use any one at all. After a long time, it drops again, and then it picks up, and then it heats up again. We're just wasting electricity, right? So what you can do is you could actually put a switch that, like a timer switch. If I need water heated up for me to probably have my bath, and all I need to do is remember to put it on 10 minutes before I have my bath, and it heats up for me for that 10 minutes, and then it goes off on its own, right? So you can use a lot of controls to save on your water heaters. Your chiller systems are massive guzzlers of energy, right? Sometimes it's expensive to overhaul them, to change major components like compressors in them because of the costs, very prohibitive. So VFD will help lowering the chiller condenser water temperature, upgrading the pump motors with more efficiency one, variable speed process chilled water pumping, improve chiller performance by increasing load factor and digital control of process cooling system. So we have some systems in Max-migold. We work with some British organizations that provide solutions that can be embedded into the control systems in your chiller so that they can work based on demand. So if your chiller comes up and there's no demand, there's no heat load from the air handling units, the chiller will not overwork itself, unlike many chillers that are old right now are doing. All right, so that's our lesson for today. I hope you've been able to get something out of it. As I wrap up, I would like to just prompt everyone in this class that these are all snippets of our bigger program, the Facility Management Mastercraft starts in August. We're already in July, so we're ramping up preparations already. Registrations are already very advanced stages. We are offering a 10% early bird discount. So if you want to grab that, please go ahead and do your registration now and benefit from that 10% early bird discount. And when you have people in your organizations registering together, like I told you, we normally will shock you with the kind of discounts that we can give. Okay, so try us, bring up the numbers and see what you can get from us as you do this. The link for the training, it was here yesterday. I believe it should be here again today. Click on it and just have a read. Paul, please drop it in the chat so that people can have a read. Click on it and then go straight into the web page to read and tell yourself if this is going to be good for your career. And if you know someone else who is going to benefit from it, please send the link to them. Don't forget to call Max-migold for any audits you want, energy audits, any projects. As far as facility management is concerned, we have the team to support you, to help you succeed. Join our Telegram group. We're going to continue the conversation there. If the chat for the Telegram group is there, just click on it and join the group. Put in your questions there. I'm still on my seat. We're going to continue with the chat and the videos. A lot of people have asked about the videos. They'll be made available. The videos will be loaded into our YouTube channels, and the link to the video will be shared in the Telegram group. That's our primary mode of interaction or communication with all our followers. That's our Telegram group. We also have a Facebook group. It's also called Facility Management Training. You can join that group if you're on Facebook, and I'm sure you're going to have a lot of advantage hanging around and same kind of value we drop for you on a daily basis. Thank you and have a good evening. Bye-bye.
Bye.
Thank you.
Thank you.
Thank you, sir. Thank you.
Thank you.
Thank you very much, sir. God will bless you.
Thank you very much.
Thank you very much.
All right, sir. Bye.
Thank you. Thank you, sir.
Thank you,
sir.
We hope to see you at some other training soon, okay? Bye.
Thank you.
Thank you, everybody. Mayowa, Jalo. Sádùúgbò alófẹ́sùn. Ọ̀dọ̀ pásítọ̀ ló fẹ́ sùn. Táǹkì kọ́ rè lọ́rùn rẹ̀. Ọmọ wọn ti gẹ̀ tiẹ̀. Ọ̀rọ̀ owó ìṣẹ̀lẹ̀ kékeré. Ó yá. Yá lọ ni. Olúwa ó ṣe. Má ṣe rẹ̀ o. Wọ́n ti ní ká measure risk wa. Àmì o, èmi kò ní kú. Èmi tẹ́sọ́kẹ́ ẹni rẹ̀ lọ nìyẹn tó bá lọ. Nísùn tó bá lọ sí báyìí. Ẹni rẹ̀ lọ nìyẹn o. Ẹni rẹ̀ lọ nìyẹn. Ẹni rẹ̀ orí ẹ̀ bu, orí ẹ̀ ò pé. Bó ṣe máa wá tó dáa.